All right, so this lecture is going to be more or less a supplement to chapter 6 in the book on marketing research. So I teach marketing research, and so I thought I would sort of cobble together some things that I thought were important for you all to know as intro to marketing students. So first off, I would say, when you think about what marketing really is, or marketing research really is, both. It's a search for empathy. It's trying to really understand our stakeholders' perspective so that we can design products and services for them, that deliver value to them, that do a job for them. So increasingly, I would say all of business is sort of adopting this perspective that we don't do a great job at understanding our consumers. The problem is that it's just difficult to empathize them. We're over here in our company working on our widgets every day, and so we tend to think about widgets in a particular way that may not be the same way that the marketplace thinks about them. And so marketing research is trying to figure out how people think about widgets, what value the widget provides them, what service it does. All right, so that's my sort of larger point. I used to call it not a search for empathy, but a search for clarity. So also what marketing research gives you is it gives you insight into the path forward. So you do some research, you get some insights, and you say, okay, this way forward is better than the other way forward. So if that's the case, then it's important that our research be accurate and good and informative, because we can get into situations where it's not. So there's a famous quote often attributed to Mark Twain that there are lies, damn lies, and statistics, with statistics being the worst. There's actually a couple of famous books on this topic. The old one is called How to Lie with Statistics and points out some of the ways that people mislead others with numbers. A more recent version that's really great is called Calling Bullshit, by a couple of faculty out of University of Washington, I believe. And so this is a lot of these examples are from this book in particular. So I wanted to talk about two types of lying. So one is outright lying, and that rarely happens in practice, actually. So outright lying might be making up data, making up results, just fabricating generally some kind of result with no basis in reality whatsoever. That's not usually what happens. Usually what these guys call bullshit, or what I call misleading here, is that what you do is you collect some data and then you present it in a particular way, or polish it in a particular way in order to create a particular perspective. So you see in this picture, there are some stones arranged or kind of hanging there. When you shine a light on it, it looks like there's a bird flying, but actually it's just these random blobs that are floating there. So this is, what most deceptive marketing research or inaccurate marketing research looks like. In both cases, marketers are just trying to tell a particular story and probably believe that story is true, but they are sort of making choices that maybe present the data in a particular light. All right, so the classic example with this is tweaking the y-axis. Right, so we have the y-axis would be the vertical axis, and the x-axis is going to be down here. What you do is this: if you look at these graphs closely, you'll notice that both of them present the same data. The only difference is one of them presents an entire 7-point scale, which we might typically measure something in marketing, and the other one goes from 5 to 6.6. The effect of that is that it makes differences look much larger and more exaggerated. You see this kind of thing in the media all the time. Anytime you see a bar chart, the first thing you should do is glance over at the y-axis and see if they are presenting the entire scale. If they're not, you know that probably they're doing that to exaggerate the difference between those two bars or multiple bars. You find interesting versions of this as well. It's not always the y-axis that's truncated. So this one here on the left-hand side, you see the number of gun deaths in Florida. And if you look at the chart sort of casually, you see that, okay, well, in 2005, Florida enacted the Stand Your Ground law. And it looks like, murders by firearm like dropped precipitously, right? So you have this thing happen, and then you see this downward motion of the line. Well, the thing is, if you look sort of carefully at the axis, the y-axis in this case, you'll see that 0 is at the top, and then the numbers get bigger as they go down, which is not conventional, right? Conventional will be the 0, 0 point is at where the x and y meet, and numbers get bigger as they go up. But for one reason or another, the creator of this graph decided to switch it so that 0 is at the top and number of deaths went down. So actually, what happened was that murders committed by firearms spiked, according to this data, after 2005, although it looks like it goes down. Here's another interesting one. Here in this one, they've on the one on the right-hand side, they've tweaked with the x-axis. So you'll see along the hash marks along the bottom, we're going 10, 20, 30, 40, 50. And then when we hit 90, all of a sudden we're going 90 to 99, 99 to 99.9. So 99.9 to 99.99. Each time we go, we start to get a much smaller unit. So here we're going by 10 percentiles down on the left-hand side of the x-axis, and up in the top, we're just each hash mark represents a 1,000th of a unit change, right at the very top one, or 100th, I guess, going from 0.99 to 0.999. So what that has the effect of doing is, what would happen is, if you can imagine, if we kept continuing this, you would see this end of the bar chart have a much steeper slope. So instead of spiking up immediately, what we've done is like stretched that out as far as we can possibly do it to make that slope seem more gentle. And what this is income growth per adult at different income group levels. And so what we see is then it sort of de-emphasizes that top 1% in terms of this, how drastically it would increase. All right, so number one way that people try to fool you with data is to start screwing around with the x and y axis. Here's one that I hadn't seen before, but actually I think was maybe from the Calling Bullshit book. What they've done here is they have two y-axes, and they've put one on the left-hand side and one on the right-hand side, and some of the lines, most of the lines except for one, refer to the normal y-axis, and then the other one references the y-axis on the other side, and those are on different scales. So you can see what it looks like. If you look at countries by military expenditure, it looks like, China, which is the solid red line, has outpaced the U.S. and now is spending more than the U.S. in terms of military, which is the blue line. However, that's not actually the case, right? If we put them all on the same scale, then the U.S. would be like its lowest point of all time in 1998 was somewhere around, $475 billion in military expenditures, which is not even on the chart on the right hand side. So that entire line would be moved up like double the amount, but that would just tell the story that the US spends like exponentially more than other countries on their military, and maybe we don't want to tell that story. Maybe the story we want to tell is that China is spending more than us on military, so we need to spend more and more. So actually what it is, as per the latest point in this data, China is looking like around 270, and the US is right around 780. So it's like almost triple the amount, right? So the chart looks like, the way they've sort of screwed around with the axes, it looks like China's spending more, but actually the US is spending like triple the amount of our nearest competitor. So, trying to tell a particular story. Speaking of statistics, so another way you can screw around with data is by cherry picking the statistics. So you probably remember mean, median, and mode from your math classes in grade school. You know what an average is. You know that a mode is the most common number. You know the median is the one in the middle. One you might not have encountered is top 2 box, which is the percentage of people that click the whatever the top box or the top 2 boxes in the scale. So net promoter score from a previous video would be a top 2 box. But then they subtract the bottom ones. But anyway, I digress. So what the thing is if you have perfectly normally distributed data, so you have a symmetrical distribution, all of those points are the same. But once you start getting a skew, say it's income or spending or some other sort of variable that's prone to skewness, satisfaction, you can drastically tell different stories by reporting either the median or the mean in particular. So the median does not take outliers into account, right? It's only going to put whatever the middle value is, so it ignores the outliers. The mean or the average incorporates those outliers into the picture. So I think this is sort of a nice, comic illustrating this point. The basketball coach is saying, okay, well, do we want to intimidate them and report the mean by including the super tall kid, or do we want to lull them into a false sense of security by only reporting the median, which is sort of an average, normal sized kid? And so you can tell different stories by picking different statistics. Here's another fun one. These are the correlation between murders by steam, hot vapors, and hot objects, and the age of Miss America. And if you'll notice, they are almost perfectly correlated. So, does the age of Miss America cause people to be murdered by steam? Probably not. But there's all sorts of these spurious correlations or accidental correlations that are all over the place. And this is why we often hear the phrase, correlation does not equal causation. So this is another just kind of a fun example. And more generally, know that marketers or anyone that looks at data has a tendency to make a story out of that data. We look at it, we're going to see some pattern, we're going to build some story around that. But what we should know is that patterns are just happening randomly. This kind of thing happens randomly all the time. And what we don't want to do is build a story around a random pattern, right? So at the sort of philosophical level, this is what statistics is for, to keep us from building stories out of results that are just really should be interpreted as random chance. All right. Here's another one. This one's related to sampling and I think sampling, or no, you're not sampling, but just the possibility of data being in existence. So if you look at this chart, you see that in particular like hip hop and rap and punk musicians and metal tend to have a much lower average age at death than say blues or jazz or gospel. And so you might build a story around that saying, maybe rappers are involved in a lot of violent incidents that cause them to die at a younger age, and that would be consistent with media coverage that we've seen. However, there's a caveat to this, is how many 80-year-old rappers do you know? None, right? So rap hasn't been around for, 80 years, so there's no possibility of a rapper dying at age 80. Whereas for a blues musician or country or jazz musician, those genres have been around for a long time, so you could live a full life and die of natural cause of old age as a jazz musician, but that's not yet possible as a hip-hop musician. So by this, so what we're doing here is we're presenting data that actually appears to be all on the same kind of scale, but it's different data. So but it tells a particular story. All right, here's another famous example. So let me walk you through this one. So there was an advertising campaign done by Colgate, I don't know, a long time ago now, maybe 30 years ago, where the tagline was 4 out of 5 dentists recommend Colgate. And here's how they collected the data for that. They went around to dentists and they said, give us a list of all the toothpaste you would recommend. And so so this wasn't just 5 dentists, it was maybe 500 dentists, I don't know, but they each of them listed this all the toothpaste that they would consider recommending to their clients, their patients. So what you'll notice is that actually, what you will notice is that for Crest, actually Crest was on all of them. So Crest, using the same method, would be able to claim 5 out of 5 dentists recommend Crest, right? So Colgate, though, is probably hoping you will infer that 4 out of 5 dentists list Colgate as their number one choice, but that's not exactly. It's easy to mislead the information, right? So it can be misinterpreted in a number of different ways. So this is actually, it's not that they were the only toothpaste that was recommended. It was that they were somewhere in the mix. So when you see these sort of descriptions of data, you always have to be a little careful. All right, misleading-ish with data. So typically when we present bar charts, you'll see something like this, where it's this rectangular shooting up into the sky with a nice clean line at the top, and that represents usually the average of some thing that's measured in some sample of some population using some sort of method of reaching into that population, be it emails or surveys or paid samples. And then the idea is that we use that estimate to extrapolate into the whole population of interest. So what happens, so the way you should think about bars is they are an estimate, and they are a flawed estimate, and that they are just really representing a best guess, not a precise value. But the way we look at them and we say, oh, okay, well, this is exactly what it is. We tend to extrapolate that value too much and not realize that underneath that is a distribution of data, and that distribution of data is also measured with error. Here's what we would actually like to see, and what we do in class, in my marketing research class, is we attach confidence intervals to the top of every bar to remind ourselves that while that top of that bar is the best guess, the true value could be anywhere in that confidence interval. So just when you're looking at bar charts in the newspaper or in a marketing research report or wherever, remember that those are just estimates and that they are measured with error, and that the top is not like a strict, precise line, but it's really this like fuzzy zone where that's maybe the most likely value, but a number of values higher or lower than that are actually possible. So on this chart right here, if you look on the pro-social identity one, none of those bars are actually different from each other. Statistically, they're all the same height. On the warm glow one over there, those are actually different. If you look at the dots, so here on the upper right graph, we don't have bars, but we have dots with confidence intervals. The first 3 are all statistically equivalent from each other, but the fourth one is statistically different from the other 3. So really we're looking at 3 averages that are the same and one that is different from 1 and 2 but not 3. So it's just important to know that things are measured imprecisely, and that not every person in the group has that value, but rather it's sort of represents a distribution. All right, another way of sort of misleading with data is we tend to focus on statistical things. This happens more in academics than in practice, but we ignore effect sizes. So we have to think about not just whether something is statistically significant, but whether it's practically significant. So does it make a difference that I go from 2.4 to 2.1 or 2.2 on some scale? Maybe not. Misleading with data number 5, this is another classic. The 3D pie chart. Both of these pie charts are with the same data. Only one has been tilted away so that the blue slice we want to look small is actually way in the back. Also, because it's 3D, we've added this sort of dimensional aspect that increases the red even more. So we want that blue thing to be smaller, so what do? We tilt it so it's in the back, so it's farther away, and then we add this 3D element to the red to make it look even bigger. Sometimes people just get artistic with their charts because they want them to be attractive instead of, going for accuracy. So you'll see this a lot in sort of, popular press kind of presentations of data that they want to look attractive and not so much worried about whether people are actually interpreting it correctly. Misleading with data number 6. So there's a nice quote from the book that says, correlations don't sell newspapers. So we always want to make a cause and effect relationship. So we've said correlation does not equal causation, but that's not that interesting, right? We want to tell a story. So so here's an example from the book where they say, what's the correlate? We find a correlation between self-esteem and kissing. So is it that if I have high self-esteem, I'm more attractive and therefore I do more kissing? Or is it that kissing someone boosts my self-esteem for some reason? Or is it maybe that there's some other third variable out there that isn't in the model, like physical attractiveness, that boosts both self-esteem and kissing at the same time, and is this exogenous third variable that is actually creating both, and that there's actually no relationship between self-esteem and kissing? So, there's rarely the case that in popular press kind of presentations of research that we sort of think up these alternative explanations. Mostly we see some correlation, we write a story that's most interesting around it. Self-esteem or kissing causes self-esteem. And then we use that story to sell newspapers. Selective binning. So what we have here is, again, the same data that is presented in different ways. So if you want it, so here what we've done is we've taken some numbers of people and divided them into income groups to show like where the wealth is. So depending on how you make the bin, so if you look on this top one, if we want to tell a story where we should tax the poor, we make our first bin $0 to $100,000, and then it looks like most of the money in America is in around the poorest people. If we don't want to tax the poor, we want to tax the middle class, then we add a 0 to 25 bar, which is smaller, and we have a 25 to 100 bar, which is $70,000 income, and we show that that's the biggest bar. However you chunk the data, you can tell entirely different stories. You can show, the poorest people have all the money, the richest people have all the money, the second poorest people have all the money, the second richest people have all the money, all by like just tweaking the bins. This is another reason why, in my marketing research class, I strongly advise against, collecting data with these type of bins in surveys, because you never know, unless you understand the distribution in the first place, you never know what you're going to get. So it's always better to collect the data at the sort of open-ended ratio level exact values rather than using these kind of categories whenever possible. This one is just, some sort of weird data selection. This is the one skewing a little bit more deceptive. So it turns out that if you only focus on the months of October to April, so October, November, December, January, February, March, April, so half the year, then you get this trend from 2011 to 2013 where it looks like border apprehensions are going up, which is a story Fox News might want to tell for one reason or another. However, according to this article, if you did all the data from the year, it would actually show a downward trend. So they were able to find these pieces of data, and again, they put in there what data they used, but nobody's going to notice that, right? So this one made the list of BusinessInsiders.com's 27 worst charts of all time for that reason. All right, so how to think critically about data. So when you're presented with some kind of result, here are the steps you should go through in order to make sure you're interpreting that data correctly. One is make sure that the X and Y axis represent the entire scale and it's not sort of stretched or pushed together in different sections or anything like that. Also check to see what statistic is being reported. So most of the time if it's a bar chart, it's going to be an average, but you never know. If it's a top 2 box, it's worth asking, well, what happened on the other side? What happened in the rest of that distribution? If it is a mean, you can also, if you see a bar chart, you can draw in your own confidence intervals if they don't have them. Now, this is kind of a little bit advanced, but the way you would do that is you would estimate what the possible range is, divide that by 4, and that would give you the standard deviation, and then you would divide that by the square root of the sample size, and that would give you the standard error, and then you go plus or minus 2. That's probably a bit more than we are going to do here in Intro to Marketing. But the larger point is that we just draw in like a little line that shows you, okay, remind yourself that top of that bar is not a precise value, it's just a best guess, and the real value is somewhere in this range. That will change the way you look at the bar chart. Also, question causality. So there's going to be a story. People show you bar charts because they want to tell you a particular story. Always sort of think about what might be the alternative explanation. Might the causality go in a different direction? Does self-esteem cause kissing, or does kissing cause self-esteem? All right, the way to not mislead with data yourself is avoid pie charts and other creative kind of things. Report multiple summary statistics. Always represent the full scale on the y-axis and the x-axis, and some sort of indicator of precision. If you're doing bar charts, you might want to do confidence intervals. If you're doing a statistical analysis, you might just do a p-value. So if you don't know what you're looking at, you're in a meeting and you're seeing some charts, not sure what it is, just nerd out. Say, what stat is reported? What's the scale? What would the 95% confidence intervals look like? This is going to sound like you're a sophisticated consumer of information, not like you don't know what you're looking about. So don't ever be afraid to ask questions when people are sort of telling you a story with some sort of research report. So how this material is relevant? Well, I think if you can hold marketing research to a higher standard, it will make you look impressive in your job. And, also this is about sort of flexes your critical thinking skills. So don't just let people tell you a story. Make sure you're being careful in interpreting that information, because oftentimes the people who are telling you that story have an agenda and they're trying to present a particular point of view to you that may not be the most accurate. So this goes not just for your job, but in general, try to hold data to a higher standard. All right, so that is my sort of way I thought I could add value to what they talked about in the chapter and try to make you a bit more sophisticated in how you consume data in your daily life. So